name's Theodore, and I'm pretty much the software slash embedded lead for the RoboSub, and that pretty much.
Hi, my name is Cesar Robles. I am the project manager for the RoboSub team.
My name is Moises. I'm the team lead for the drop marker.
Design allows for camera dynamics, which in effect gives us power efficiency because the camera assembly can move on its own, and so it doesn't require the entire sub to move. And for the drop marker, we have also some energy efficiency designs by using neodymium magnets instead of electromagnets. So that means that all we need to drop a marker or to hold on to a marker is a servo. And we have a maximum load capacity of 550 grams. And so this allows for a safety factor that is large enough to account for eddy flows or turbulence with moving a sub and also holding on to the drop marker. And we have a confidence level of 75%.
So as far as testing and development, we have not been able to test the whole sub as a whole. However, we have been able to test individual components. Also, another component that we've worked on is the marker dropper. As Cesar mentioned before, we do have a 550 gram max load that the marker dropper is able to sustain. However, we did want safety factor in there just in case we do have more forces that are going to be acting upon the marker dropper. So given it a safety factor of over 2, we did machine down the marker to be 200 grams. Now for the marker dropper, we are locating one in the front and then another one in the back.
As far as testing the other components, we didn't get as far into actually working on software for the arms or the torpedo, and we plan on finishing the software and simulation for the camera sensor here, making sure that the rotation of it is programmed in as well as the image recognition, and we'll have our teammate Theo talk more on that.
As we have made the most development during these past, these very recent years, we've kind of made sure that our whole platform is developed around the chance that, we won't have access to the water or anything. So we kind of do a lot of work on the software and embedded side to kind of have this adaptability on our platform where we can test consolidated things, so we can run the Arduino without the Raspberry Pi and it can still do something, and we can test all of the facets of each individual subsystem of our entire code application just on these individual boards. And so, as well as kind of the adaptability of our entire platform, we have a Unity simulation that we actually use to test and train both a TensorFlow model and then just our general OpenCV scripts that we use to locate the buoys and the gates and kind of find where our nav marker needs to be placed. We also have a conceptual kind of for when the RoboSub would actually be running in the water, it would be mapping out its entire environment in a way that and saving it in a form where after the mission ends, we can actually use that data to improve future missions, in all sorts of ways, for remembering exactly where the nav marker was and if it was a success or a failure. We can go in and look at that as programmers and kind of like manually debug things, but when our sub can autonomously take mission data back after running through its commands, then and intuitively work through kind of what worked and what didn't work on its mission, then that's what we're going for with that conceptual side. Testing and development pertaining more to like the software embedded side of the sub, we definitely wanted to think about this a lot because it's our main thing, is to really make sure that we can run the sub in some fashion, and so our code platform kind of allows us to test individual things. So, if we wanted to just run something using the host computer or the Arduino, we can do basic functions with any of them kind of consolidated, any of the boards or sensors consolidated from each other. And so this allows for fail-safes during missions. So, if something comes unplugged, it's like, whoa, watch out, let's run this at like the most basic version. We also have a Unity simulation that was developed last year where we were able to actually train AIs and test our OpenCV scripts that we're developing for vision recognition. But there's also some conceptual OpenGL mission simulation where while the RoboSub would be in the water, we haven't done full testing as Moises and Caesar brought up, but when the sub would be in the water, it would be able to record like a coordinate map of the things that it sees, and even just walls and basic things as the buoys or the gates or the places where you have to drop the marker, and so kind of saving these waypoints in a sense that we can record them both just like as the coders, we can go in and look at this telemetry from these failed or successful missions, but also the sub, the code application actually does a little bit of basic like remembering of, oh, this is what worked, this is what didn't work, and perchance to that simulation that it kind of recorded a couple times ago. So more and more testing equals more and more data, good data back for us to improve the sub.